Good morning, dear authors and invited guests. Welcome to the technical session 4D. Myself, Saksham Sarraf, and this session will be moderated by me. On the behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you in the International Congress of Communication and Information Technology, ICICT 2023, London, United Kingdom. The offline version of this conference was held in London on 20th and 21st February, and the online version is held through Zoom. It was held yesterday and it's held today, that is 22nd and 23rd February. I hope you will enjoy interactive sessions throughout the day. In this session, we will have 6 presentations and each presentation will be given 12 minutes for the presentation and 3 minutes for question and answers. And I'll read a gentle reminder in 10 minutes. So I request you all to stay connected with us till the closing remarks. And if there is any query or any update, you can just write it to me in the chat box. So just before starting the session, I would like to introduce you to our session chairs, Dr. Kanagaran Fanifong and Dr. Preeti Parevar. Dr. Kanagaran received his BBA degree in Information System in 2005 from Rangmala University of Technology, Thaianburi, Pathum Thani, Thailand, MBA degree Business Administration in 2008 and DBA degree in Business Administration in 2018 in Pathum Thani University, Pathum Thani, Thailand. He is currently a lecturer at the Faculty of Business Administration and Information Technology, Rangmala University of Technology, Taiwan, UK, Bangkok, Thailand. And Dr. Preeti Pavekar is an associate professor in Department of Computer Science and Engineering, Faculty of Engineering Technology. She has been an academic for last 20 years. She has been awarded PhD in areas of wireless sensor networks. She holds a life membership of IEEE, ACM, CSI, ISTE. She had also contributed as Computer Society of India State Student Coordinator and for 2 years. Her research interests include Internet of Things, cloud computing, machine learning, wireless sensor network, software engineering, information retrieval system, social media, data mining. She has published more than 50 research papers in peer-reviewed journals with SCI, SSCI, Scopus Index, and in the conference proceeding of Springer and IEEE. Thank you for your presence.
Thank you, Saksham.
Thank
Now,
you.
I'd like to move forward and I'd like to invite our first presenter, Enrico Cambasi.
Hello to everyone.
With his, yeah,
Can you hear
this
me?
paper on the, yeah, you may start your presentation.
Okay. Can I share the screen?
Yeah.
Okay. Great. Just a second. Can you see my slides?
Yeah.
Sure.
Yes.
Okay. Very good. Good morning to everyone. I'm Enrico Cambiaso, and I'm going to talk to you about the use of low-cost IoT hardware to execute the denial of service attacks. We all know that there are various kinds of denial of service attacks, but we will focus on slow DOS attacks that require minimum amount of resources to the attackers. And in particular, we will focus on a specific attack, which is called SlowCom and is available in literature. Back in 2014, we have been the first in our research group to demonstrate that a single mobile device can be is able to execute a successful denial of service attack against a conventional server. What we want to do now is to push the limit further and to prove that a single IoT device is able to execute the same attack against a conventional server. We all know that in history, in the past years, IoT devices like smart cameras or even Raspberry Pis have been used to perpetrate this kind of attacks, and maybe the Mirai botnet is the most important example in this scenario. But we will focus on low-cost hardware like the ESP8266, which is a microcontroller providing Wi-Fi connectivity and with very limited resources, very limited capabilities. It is also very small and cheap. It costs around €2 for each piece. And because of this, we may state that a potential attacker can easily and without spending too much can distribute a botnet around the globe by hiding this kind of devices around the globe. Before continuing, I don't know if you see the slides or if it's partially hidden, but maybe now it's visible. Before continuing, I would like to introduce some useful parameters that will describe in detail the tests that we have accomplished. And at right, you can see the behavior of the attack and the effect of the attack on the server. This behavior has been computed and analyzed on the targeted server itself. And we define NC, the number of attacking clients, of attacking IoT devices. And S is instead the number of, sorry, I have to, okay, the number of connections that the server is configured to manage simultaneously. This means that if all these connections are established, are managed by the server, any new additional connection will experience a denial of service. NA is instead the number of connections that the attacker is configured to keep constantly sized on the server. This value can be equal to NS or even a different value. MPIC is the maximum of the attack function, while P desired is the percentage of time the victim is in the state desired by the attacker. For instance, the DOS state, but the state may be even not to reach the DOS at all, but a different state. And finally, eta desired represents the impact of the attack on the server, and it is computed as the integral of the attack function normalized in function of the aim of the attacker. We have executed the first test by targeting an Apache 2 web server on its default configuration. The default configuration of Apache 2 is able to manage at most NS equal to 150 connections. So we configured NA, the number of connections established by the attacker, equal to NS, so equal to 150. And the result is available in the slide. And you can see that all the connections have been established from the MPIC value. The attack impact, eta desired, approaches 1, and this is very good as a result, while the P desired, the percentage of DOS experienced on the server, is around 57% of the time, considering our observation window. This means that this is related to a specific module, which is called rec timeout, and is enabled by default on Apache 2. It is possible to bypass this module, this protection module, by improving the attack performance, but this is out of the scope of our paper. Just to let you know, in case we disable the rec timeout module, the P desired value approaches 1 as well. What we have done then was to increase the capabilities of the server by setting the NS value to its maximum value. And this value is equal to 256. So we executed again the same attack with the NA equal to 256, and the results are not convincing. When we have the MPIC value equal to NS, the eta desired and the P desired values are not convincing. So we decided to analyze the behavior of the attack and the effect in terms of these three values, MPIC, eta desired, and P desired, by varying the number of connections established by the attacker. So by varying NA. This is the result where it's possible to see that after and for NA greater than 170, we have some kind of unexpected behavior. By analyzing in detail the behavior of the attacker, we found that the ESP8266 experiences crashes for NA greater than 170. So we have identified the first limit of our IoT hardware, which is NA greater than, which means that the attacker, the single IoT node is able to establish at most 170 connections. So we decided to run the same attack, but in a distributed way. So we have NC equal to 2, so 2 different nodes, establishing each NA equal to 150 and 28. What is possible to see is that the MPIC value is equal to NS, and this is good. The eta desired value approaches 1, and this is also good. But the percentage of DOS P desired is around 2%. And this is unexpected. It's possible also to see that at the first round, before connections are closed by direct timeout modules, all the connections has been established, and then there is some kind of limit on the server, on the connections, on the function that is possible to see. And this is unexpected. So we executed new tests by varying the configuration of our server, because we thought that this depended on the performance of our targeted server system. So we executed new tests by changing the number of CPUs of the server or the memory in particular, but we found that the MPIC never reached NS in this test, and the P desired values is equal to 0. So this is also unexpected, but we decided to change the approach. Instead of analyzing the behavior and assuming that the denial of service is experienced only when the NS connections are established on the server, we decided to add a third-party client, a third-party node, effectively checking the reachability of the server. And this is the result. In this case, we executed the same attack previously mentioned, with NC equal to 2 and NA equal to 128. And we found that the MPIC is lower than NS. Okay, and while the eta desired approaches 1, the P desired is equal to 0. But by adding the third client, the third node checking the effective reachability of the server, we found that the DOS state affected the service for 91% of the time. So what's important in our finding is that the configuration of the NS on the server, and in particular on the NPM common module of Apache 2, is not reliable. So by concluding, in this paper, we evaluated the feasibility to use low-cost IoT hardware, and in particular ESP8266 devices, to execute successfully a denial of service attack. We found that this kind of hardware is able to establish up to 170 simultaneous connections without experiencing any malfunctioning. For servers accepting more than 170 connections, a distributed attack is required. We also found an unexpected behavior on the npm common module of Apache 2, and in particular on the max request workers directive of the module. And this is surely a scope of future work on the topic to analyze why this behavior, why this configuration is not reliable, if it's related to a bug or to some kind of management that has to be investigated in depth. And also further work may focus on targeting different daemons, different applications, or different protocols, or to use different IoT hardware, or to port also different kind of slow DOS attacks, different from slowcom, to the ESP8266. Finally, of course, protection is also scope of further work on the topic. I've concluded. I think I've been in time. If not, I'm sorry for that.
Yeah,
Can you hear
thank
me?
you,
Okay.
Enrico. Am I right? Your name?
Okay.
Hello, can you
Okay,
hear?
thank to you. Yes, thank you.
Yes,
You.
very well presented paper. I have some couple of questions, if you can answer that. It's like the microcontroller which you have designed. Where exactly are you deploying it? Is it in the network or is it in the host?
Sorry, I didn't catch which element you're referring to.
IoT element which you are talking about, the low device, EPF, that particular device, where are you putting it? Are you putting it inside the host or a server or in the network?
Yeah, well, we built a simple test network composed of a targeted server, which was a virtual server in this case, just to allow us to edit the configuration of the server in terms of CPU and memory easily. And we built also a Wi-Fi network connected to this network, just to provide the connectivity to the IoT attacking node. The IoT attacking nodes, because we used 2 nodes for the distributed attack, are connected, are physical nodes connected to the Wi-Fi network, so connected to our testbed.
All right. The second question is it designed or detecting only denial of service attacks, or is it ready for detection all the passive attacks and active attacks?
Well, what we have done was to implement the slowcom attack, which is known as slow denial of service attack, on the device itself, so on the ESP8266 IoT module. And then this generation of graphics was computed on the server by analyzing just the state of the server. So there is no detection in this paper, but just some kind of snapshot of the state of the server during the attack and during the entire observation window. I can't hear you. I don't know if it's my fault or
Yeah,
not.
yeah. No.
Okay,
I said
sorry.
thank you so much. If sir has any questions.
Sir, I'm not sure. I saw Sebastian, he raised up the hands.
No, it's only tapping for him.
Okay, so far so good.
Okay, thank you very much.
Thank you.
Okay, thank you.
Any further questions, professors?
So I think can we go to the next one?
Yeah. So thank you for presentation. Now I would like to invite Amit Bankodi with his paper on realistic modeling of computer systems in GEM5 simulator. You may start your presentation now.
Okay, can you hear me okay?
Yeah.
Thank you. I'll share my slides. Okay, is this slide visible?
Yes.
Okay. Thank you. So my name is Amit Mankodi, and I'll be presenting the paper titled Realistic Modeling of Computer Systems in Gen5 Simulator. This is the agenda that I'll be covering today. So we know that when we perform computer architecture research, usually we require a large number of systems. Specifically, we are looking for different features of the system. For example, different CPU features or memory features and things like that. Now, just for the research purpose, many times it is not cost effective to buy the physical hardware. Also, maybe the systems that you are looking for with the specific hardware features are not really built yet. So in such circumstances, we use system level simulators, in the research purpose. So we looked at some of the simulators that are available, open source simulators that are available for the architecture research. And what we found is that Gen5 is a very well-known, well-used, simulator in the research community. And there's a specific features or reasons behind them. And those are the same features that we also liked about Gen5, and that is why we have actually used Gen5 in our research. So some of the features that I'll mention which are important to us is, first of all, in Gen5, you can simulate the system in two different ways. One is called full system mode, where you can actually build a complete OS, design, and regular system like a virtual system we can build using full system mode. The second option is system call emulation mode. Now, when you want to build system using full system mode, it's very complex and time consuming. So you can build systems rapidly and easily using system call emulation mode. So this is why we actually chose that particular mode of operation or simulation. The second advantage that Gen5 gives us is it supports 6 different instruction set architecture, including ARM architecture and x86, which is what we are interested in using. The third advantage is it supports various processor types, but more importantly, it uses out-of-order processor, which is always used in the commercial systems today. And to us, one of the most important advantage of Gen5 is that it can be used in conjunction with another tool called MacPath. MacPath tool allows us to collect the power consumption data of the application when you execute on a Gen5 simulated system. So in case if you want to, work on the research of, power reduction, we know that computing system today generate a lot of power or consumes a lot of power, which generates a lot of heat that is causing environmental hazards. So for such research, also you can use MacPath and Gen5 together. So we wanted to build real systems in Gen5 for further research. So what we did is we collected features from the real systems. We have classified those systems into these 8 categories. So some of them are using AMD processors, some are using ARM-based processors, and some are using Intel-based processors. And we have collected 9 different features from the systems, 3 of each of the component, CPU, memory, and cache. So these 9 features were collected from the real hardware, and we wanted to build all of these systems in Gen5. So when we started doing that, actually we encountered certain challenges, and that is actually the focus of the work in this particular paper. So we primarily encountered 3 challenges. The first challenge was that the current implementation of Gen5 simulator supported 2 level of cache hierarchy, whereas most of the commercial system supports 3 level cache hierarchy. Secondly, there are many memory modules that we wanted to use, which are used in the modern systems, but currently they are not supported in Gen5. And even though Gen5 supports out-of-order processor, its implementation is based on one particular type of system. So basically, it is based on the Alpha 21264 processor with the 5-stage pipeline. So these are the challenges that we plan to address. So the first challenge that we have is, 2-level cache versus 3-level cache support. So the figure on the left is actually the current implementation of Gem 5. And we can see that it uses 2-level cache hierarchy with L2 cache as a shared cache. On the right-hand side is the figure is where we want to go. So we want to add a 3rd-level cache. In addition, when we are supporting a 3rd-level cache, we also need to support individual L2 cache to the architecture. So we need to have individual cache support as well as shared L2 cache support as a backward compatibility. So in order to implement this particular architecture, we proposed changes to Gem 5 source code. So the first change that we have to do is in options.py file, where we add 2 different options. One option will basically say that whether you want L2 cache to be individual or shared. And a second option will tell you whether you want L3 cache or not, because some of the small systems like embedded system even today may not use L3 cache. And if you want to use them, if you want to simulate them in Gem 5, you still have to allow to not have L3 cache. So these are the 2 options that are added in options.py. Caches.py is where we actually add the L3 cache class. Xbar.py is where we actually add the switch for the connection to L2 from L3. So here you can see that we have L3 Xbar switch connecting L3 to L2 cache, and that is what we are adding in the Xbar.py. And finally, in the cache config.py, we are basically making all the connection by looking at the 2 different flags or switches that we have provided. So if the L2 cache is going to be individual, then we have to connect each individual L1 cache to individual L2 cache. If the L2 cache is shared, then all the L1 cache will be connected to L2 cache and so on, right? So if the L3 cache option is provided, then L2 caches will be connected to L3 and then L3 will be connected to DRAM. If L3 cache option is not provided, then L2 cache has to be connected directly to DRAM. So in short, all the connection part that we need to figure out, that is all performed in the cache config.py. The next challenge that we focus on is addition of some memory modules in Gem 5. So the table on the left actually shows all the memory modules that are currently supported, and the table on the right are the memory modules that we would like to implement. So we can see that if you see, some of these memory modules are based on some data sheet. So what it means is that there are certain values from the data sheet that is being used for implementing this module, and most of them are using Micron architecture or Micron systems based data sheet. So that is what we have also done. So for the memory modules that we wanted to edit, we found the equivalent data sheet from the Micron systems, and we collected specific features such as clock take, data refresh rate, the current values, and so on. And we created the class for each of these memory modules in a file called DRAMcontrol.py. This is how we can add the memory module in Gem 5 simulator. The third challenge is the specific processor design, which is based on a single type of processor. The features of that processor is actually mentioned on the left-hand side, this table. Adding more processor design requires a lot of effort. It's very challenging also. So we were not able to achieve that in this current implementation of the paper, but definitely we are considering it as a future work. So for the evaluation part, we have made all these changes to Gem 5. How do we evaluate the system performance, right? So what we did is we built these 475 different systems in Gem 5, and then we used 3 different commonly used applications. Monte Carlo algorithm, matrix multiplication, quicksort, basic algorithms with different problem sizes. Now, in order to run these applications on these Gem 5 systems, we first generated binary using the same host system. The reason we want to do that is so that the execution of the application is not affected by the system software such as operating system, the compiler version, the optimization level, and so on, right? So that is the reason we compiled all these three applications on the same host machine. And we use the GCC compiler to compile the x86 based the binaries. And for ARM binaries, we use the GCC cross compiler, but again on the same host system. Once we compiled, all these three applications were executed on 475 Gen 5 systems. And we evaluated the performance of the simulated system by plotting the hardware feature against the runtime. And once we did that, we basically analyzed the plots. And what we observed is we primarily made these three observations, which are usual observations that we would normally see in the system. So first of all, when we look at runtime is inversely proportional to the clock speed, the cache size, and the memory block. The slower memories like LPDDR2, LPDDR3 requires higher runtime in comparison to the slower memory types. And one particularly, the memory clock, when it goes higher than 1600 megahertz, the runtime is significantly reduced, right? So this is the observation we can make from running an application on the Gen 5 simulated system. Now, how do we compare this result with the physical system, right? So we need to ensure that these results are also observed on the physical system. So what we did is we selected 9 physical systems from our lab computers, and we collected their specific hardware features, which is listed in this table over here. We also ran the same applications on these physical systems. And again, we plotted the hardware features, against runtime. And if you look at the plots look pretty much similar to what we see in the Gen 5 simulated system, in the sense that runtime is always inversely proportional to the CPU clock, memory clock, and cache size. Slower memory requires obviously higher runtime compared to the faster memory. And again, the memory clock greater than 1600 megahertz requires much less runtime. So the same observations were noticed in the physical system as well. So we can say that the modification that we did in Gen 5 is working in line with what we would observe in the physical system. So in conclusion, I would say that we have identified the challenges to implement the system in Gen 5 simulator using system call emulation mode. And we have addressed those challenges with proposed changes. With the modified version of Gen 5, we can emulate the system with the hardware features which are more closer to the real system. And when we compare the result of the physical system with the simulated system in Gen 5, we observe the same kind of behavior between the two systems. So this is our conclusion. And for the future work, as I mentioned, we will be working on updating Gen 5 for newer processor designs that are available, because today processors can have 5-stage pipeline, 7-stage pipeline, 9-stage pipeline. So all those changes that we would like to make in Gen 5 in the future. And that's all I wanted to cover. Thank you everyone for your time.
Yeah, thank you, Amit sir. Can you hear me?
Yes, I can.
Yes. Now, I have some questions. It's like, as far as I know, Gen 5 is a simulator. It's open source.
Yes.
And you can use it for academic research or industry.
Right.
Depending on the companies as ARM research or AMD research. So when you have designed this simulator, are you looking at the industry purpose or academic purpose?
So currently I'm working from currently I'm working at academia. I'm looking at the academic purpose. In fact, we are focusing on working in the performance modeling area using this particular simulator. So that is my research area where I want to work.
All right. So when you are considering the academic research, you need to consider the constraints. I mean, what are the constraints of the academic research? Based on that, your simulator would be designed. So have you considered it?
Yeah. So as I mentioned, we have, once we modified the simulator and we collected the data from the simulator, right? In order to ensure that the simulator is working in line with the systems that are available, that is why we actually compared the result with the physical systems, right? So the 9 physical systems, the features that I mentioned, they are the systems actually used in our own labs. So I went to the labs and found out that, okay, what are the physical systems which has different hardware features. So each of these systems does not have the same set of features. And that is why we compared the result with the physical systems which we use in the lab versus the GEM5 systems.
All right. How many cores have you used?
We have basically, see, the applications that we have used OpenMP with 1 to 8 cores.
All right. And how did you check the accuracy? Have you used FS mode?
No, we have not used FS mode, but see, the primary reason of using system call emulation mode is you can very easily use simulation mode. I mean, syscall is emulation mode to simulate a system. If I want to do the same thing in the full system mode, I need the ISO image for operating system. I need to build the drives, disk, and all that. So building one system itself will take probably a couple of days. And we wanted to build these 475 systems very quickly. So what we did is we built it using system call emulation mode. Now I know that there is a difference in the accuracy of the runtime in the system call emulation mode and the full system mode. So that is where I was mentioning that we would be performing some analytics and we will be doing some modeling, performance modeling, to see that how we can actually bridge the gap.
All right. So all the best for your work. That's all.
Thank you so much. Thank you.
Any questions from participants? Answer.
So I think no questions, and so far so good, everybody. Okay, so could you please proceed for the next one?
Thank you.
Thank you, Pretty.
Thank you for your presentation, sir.
Thank you.
Sir, she is not here, I think.
Hi, sorry. Yeah, I am here.
Okay. So next I invite Maria Teresa with a paper on sustainable technology for environment friendly and ecological reliance. You may start your presentation.
All right, thank you. Okay, so good day. My name is Joy Rocamora, and I am a master's student in disaster risk and resilience at Ateneo de Manila University. And I'm also a research associate for the Coastal Cities at Risk in the Philippines project, as well as a researcher for the Ateneo Innovation Center. Today, I will be presenting one of AIC's most recent projects, the Sustainable Technologies for Environment-Friendly and Ecological Resilience, or STEER. So for this presentation, we will be talking about the need for anticipatory action for cascading disasters due to the Philippines being a country at risk and the fuse nexus in action via the utilization of Ateneo Innovation Center's menu of anticipatory technologies. So to start off, it is no secret that the Philippines is highly exposed and very vulnerable to geophysical and hydrometeorological disasters, compounded by moments of political and social instability. These past few years, however, due to the pandemic and a cascade of other events, this has gotten more evident, pushing the Philippines to the top of the World Risk Index in 2022, with almost double the score from the year before. So a good example of this would be a single day in 2021, when a strong earthquake, monsoon rains, and flooding, and a new COVID variant all swept through the country. And then so we now know that continuous typhoons and monsoon rains not only cause flooding, which can result in property damage and loss of life, but also cause diseases and loss of livelihood, which can severely affect the survivors' lives long after the disaster. So 2020 was a particularly harsh year in the Philippines. It was a year that started with a volcanic eruption and ended with 2 strong earthquakes with a global pandemic and several epidemics happening throughout. Well, cascading events delay society's full recovery from a disaster, resulting in a lack of preparation for the next one. It has been said that disaster-prone communities experienced more difficulties in coping with COVID-19 restrictions and its severe economic impact. And this is also true for each and every disaster that Filipinos have gone through. Cascading disasters, which many are quick to constrain to geophysical, have been one of the main antagonists in the country's history, with social vulnerability and its ill effects the silent accomplice. This is where anticipatory action comes into play. So anticipatory action in the face of impending hazards contributes to reduced impact and reduced risk, assisting in faster and more efficient disaster response and recovery. Additionally, multi-hazard considerations are taken into account in order to provide better interventions. Simply put, it is extremely important to have everything in place before the event. That way, there is more focus on response and recovery than in relief. So the AIC introduces the anticipatory technologies born out of this need. The entire project is rooted in the Fuse Nexus, which promotes the inseparable links between the use of resources to provide basic and universal rights to food, water, and energy security. Furthermore, the integration of sustainable livelihoods and alternate income streams in these at-risk areas can also help improve their quality of life, especially in post-disaster time. Various configurations of the AIC anticipatory technologies have been deployed in more than 180 locations all over the country as of now. So in order to do this, AIC employed a service model approach rooted in knowledge sharing, which promotes co-innovation and co-ownership. Through its workshops, responsibility with the planning, implementation, maintenance, monitoring, and evaluation of the system is distributed between both parties, while ensuring that the beneficiaries who will be trained in the usage of the technologies and its maintenance will also have a hand for co-innovation. This presents them with a chance to transform the technologies handed over to them into sustainable livelihood opportunities. So AIC's flagship project is the Clean Water System, which is designed to be self-sustaining and can be deployed to remote and isolated areas. It is made of materials that are low cost and readily available, which makes it suitable for local government units who want to establish safe and potable water for their constituents. Their system is composed on one hand of a solar panel and lithium-ion batteries to power a UV lamp, and on the other, a plumbing setup which pushes water through a 3-stage system of ceramic, ion exchange, and activated carbon filters. There also exists provisions for charging of USB devices, light fixtures, and DC-powered appliances. So currently, there have been 181 systems deployed nationwide between 2008 and 2022. The treated water was sold at 1 peso per liter, and our partner communities can earn 30,000 pesos or up to $546 per month as return on investment. The alternative livelihood empowers the community and motivates them to maintain the system for sustainability. We also have a domestic wastewater treatment system, which can filter out 90% of the bacteria from common septic tank of 3 houses. Papyrus plants were placed at regular distances to reduce the bacteria to 10%, with a flow rate of 400 liters per 24 hours. At the end, a 500-liter concrete tank stores the treated water and is pumped out to power the plants, to water the plants. Communities can sell these small papyrus plants for 300 pesos a piece, either for use as ornaments or for basket making. So the release of agriculture grade or Class C water from the septic tanks lessens water pollution in rivers and soil contamination. This system is also found in a zero waste building on the Ateneo campus, which you can see on the lower left side of the screen. The hydroponics method used by AIC grows approximately 100 to 120 high-value green leafy plants such as lettuce, arugula, and parsley. This yields fresh produce, saves water, and lessens the use of chemical-derived pesticides and fertilizers, therefore increasing organic farming. This can be practiced in urban and rural communities, but more importantly, in communities with less capacity and accessibility to resources. So far, our community partners can harvest up to 400 cups of lettuce from a 3 square meter area in 35 to 40 days, which they can sell for around 20 pesos per cup, with a gross earning of $147 per harvest, meaning they could reach an ROI after their 6th harvest, and then profit can start on the 7th. Along with this, we have the brick stove and oven, which was created from locally sourced and recycled materials. This efficient system can provide warm food as well as indoor and outdoor heating during disasters, while supplying boiled water in the absence of potable water sources. On the side of information technology, we have the near cloud that provides the means to store, stream, and transmit files and media in high definition, which can help provide an alternate e-learning environment that can aid both teachers and their students in off-grid and far-flung school communities where telecommunications infrastructure is either weak or unavailable. Having these modules readily available at a moment's notice without the need for fast network speeds or advanced devices will help students get back into the classrooms quicker after disasters. Finally, image transmission via radio utilizes the downloadable free FastLight digital application, which can convert pictures to audio signals. This system makes evacuation and emergency response quick and efficient without depending on cell phone signals. So the information received by the local officials can be immediately relayed to municipal officers for quick response and action, or even simply just a means to communicate with family members in remote areas. So now, how did we get communities to accept these technologies? Simple. We show them a very obvious way that benefits are for them. The buy-in was achieved by encouraging people to perform water testing in their communities. Once they saw the results of this testing, it was easier to gain their trust with regard to other technologies. So we can see some of the testing plates on screen with the pink growth showing coliform contamination and blue for E. coli. So we had 30 tests conducted in multiple locations in Southern Leyte, Cebu, Capiz, Marikina, and Rizal from 2018 to 2020. And then tests showed that 13 of the 30 locations, almost half, were contaminated by either coliform or E. coli or both. From the 5 provinces, 100% of the locations tested in Capiz were positive for contaminations, while none of the 6 locations were contaminated in Marikina. For water sources, none of the tap water from the 9 schools were contaminated, while 100% of refilling stations showed contamination. This is especially worrying as water refilling stations are some of the most trusted sources for clean water in this country. So now we can see all the graphs that I have just presented. So now we have to put all of this together, the fuse nexus in action. So recently, the Ateneo Innovation Center traveled to Naga in the eastern side of the country where typhoons regularly make landfall. And through Bayanihan, a Filipino practice which refers to the spirit of communal unity, work and cooperation to achieve a particular goal, helped construct resilient housing which incorporated all these technologies. The builders used adaptive and innovative methods with recycled concrete for non-loading walls and standard aggregates for loading ones. All walls were waterproofed and oriented such that enough natural lighting will be used without the possibility of overheating the location. As the Philippines engineers disaster resilience in local government units and impacted communities, we expect to implement these net zero green construction techniques that reuse energy-intensive materials and incorporate the anticipatory technologies into new designs of safe zones and evacuation centers. One of the most important things we learned as well was that in the hands of these communities, these technologies have also been transformed into alternative income streams that can sustain them through peacetime. What results is a two-way knowledge transfer between communities and innovators with long-term benefits for both sides. Addressing the lack of electricity, water, food, communication, educational devices, environment care, and cooking facilities, all of which address specific SDGs, will definitely make communities more resilient to communities. So in behalf of the Ateneo Innovation Center, Ateneo de Manila University, Ateneo de Naga University, we thank you for listening.
Joy, right?
Yes.
Yeah, excellent work, Joy, because
Very much.
sustainable technology is in demand, and the kind of work your team is doing is really good, like for water, food, electricity, and light systems. Now, I just have two questions. It's like if there is a natural calamity or a disaster, like how fast you can deploy your service model?
Okay, so far, usually when typhoons hit the country, we are able to gather equipment and then deploy these technologies within a week or two. But that would be for new locations, because for old locations, these technologies are already pre-positioned and available for use for communities when the disaster strikes. So it will always be there for them, even during a disaster or immediately after a disaster.
Oh, that's nice. And can you put some more light on the cloud system? Like you said, there is no infrastructure available. In case of there is no infrastructure, how are you giving them a cloud facility or a network facility through a mobile?
So we use the Raspberry Pi. We're in for example, students can connect the signal given out, and it could be it is spread over a large area. So you don't need any cell phone signal or Wi-Fi signal. It produces its own signal. So students, moderators, teachers, or first responders can actually connect to this system independently and access the information that is stored through USB devices, external hard drives.
Yeah, would you mind if I have a small suggestion, if you can implement that also? In that case, you can deploy the wireless sensor networks. You can deploy the
Okay.
sensors to have a network, like ad hoc network, because you need an immediate communication at that time. So when you need an immediate communication, you can take a help of a WSN, that is wireless sensor network. That will also help you. You can consider that suggestion as this.
Okay, thank you.
Yeah, all the best.
Thank you very much.
Any more questions from anyone?
Okay, and Joy. So my section for your paper. So I think this is a good contribution in the business. But for next paper, could you please like compare the research results and in terms of the previous paper or something like the technicals and comparison, what is the good things, what is the good contributions, like more the research compare between your results and another research. So that I mentioned is term of like academic paper, but your good contribution for the business. So I know. Okay, this is my suggestions.
Okay, thank you. Yes. Moving forward, since we are continuously deploying these systems, we will be coming out with another publication, probably showcasing all the results that we have, because locations to the north of the Philippines actually can experience different disasters from locations in the south of the Philippines compared to those in the middle. So we can do these comparisons as you suggested.
Okay, all right. So so I think this is so far so good. Could you please proceed to the next ones?
Okay, thank you for your presentation, Joy. Now, I would like to invite Moneen Alatrachi with this paper on the determinants of ICT used by university professors. You may start your presentation now.
Yes, hi everyone. Do you hear me well?
Yeah.
Okay, I will. Do you see my presentation? It's visible?
Yes, it's visible.
Okay. So good morning, good evening, or good afternoon, wherever you are. So my name is Monel Atrashi, and on behalf of my colleagues, Samira Ukafi, I will present our work on the determinants of ICT used by university professors in Morocco. That I expose following this plan: introduction, the research questions, data sources, the empirical framework, and the results of modelization, and finally the conclusion. So it's undeniable that ICT have become it's undeniable that ICT have become an inseparable and essential part of economic development. So the World Bank reveals that digital can influence economic growth in different ways. So it causes an increase in investment in physical capital, an increase in productivity in ICT field, and an increase in productivity in general. So the exploitation of these positive effects requires the implementation of public policies in order to put the potential of technological progress at the service of the economic development. So aware of the challenges, Morocco has committed from the end of the 19th in a policy of development and modernization of the telecommunication sector, and which was crowned by the launch of the
Moni, sorry
national
to
plan.
interrupt you, but your slides are not moving.
Sorry?
Your slides are not moving.
Ah, okay. Now?
No, you have to just stop your share screen and again share the screen.
It's okay now?
It's okay now.
All right. The ICT policies has taken an essential part in the Moroccan policies, and it was crowned by the launch of two national plans, Morocco Numeric 2013 and Morocco Digital 2020. And these national plans they are not it's not neglect the educational issues, and especially in the higher education. The Moroccan highest planning based in a study, it's focused on it's mentioning that 47.2% of students in higher education are drop out their studies, and only 13.3% graduates rates, and the employment rates is quite higher among the higher education graduates. During the pandemic, Ben Saddeq, based on a study, shows that teachers in higher education relies heavily on their on their own resources to teach an online courses, and students they did not benefit all from the same conditions of ICT tools. So based on the alarming conditions and the alarming situation in higher education in Morocco, ICT could be a solution to improve the learning conditions in higher education in Morocco. So it's in this specific area that our study takes places on and trying to analyze the determinants of ICT use by university professors in Morocco. So, and that would be to respond to two main questions. So the analyze and identification of determinants of ICT use by teachers, and defining the professors who are least likely to use ICT for educational purposes. Due to the lack of data, we choose to conduct our own survey between May 2018 and April 2019. So we were able to investigate 223 teachers or professors in 6 different cities and 4 different regions with different levels of developments, of region developments. The questionnaires were administered face-to-face, and we choose not to distribute the questionnaire online, as this method of administration would exclude professors who use little or not at all new technologies or ICTs, which would have caused a problem of selection bias. We have identified the main variables impacting ICT use by professors through a variety of empirical studies, which we can group into four groups: the professor, the professor individual characteristics, the technological profile, the establishment characteristics, and the region characteristics. The added value of our work or our study is that we took into consideration some variables to be adequate to the Moroccan context, especially the professor grades. So in Morocco we have three level of professional grades: assistant professor, accredited professors, and the third one, higher education professors. And also we took into consideration the type of access to the establishment, whether it's an open access establishment or regulated access establishment. And we took other variables representing the level of development of the region, using the regional human development index. The endogenous variable, the educational use of ICT, is qualitative and polytomous variables taking 3 modalities. 1, if the professor has a moderate use of ICT. 2, if he uses often the ICT in teaching. And 3, if the professor uses continuously ICT in teaching. So the structure of this variable, of the dependent variables, suggests the use of the Ordorus-Probert model, the econometric model. The estimation results or outcome shows that the R-square is equal to 28%. It to remain satisfactory given the qualitative nature of the individual data. The model findings, the first finding is that indicate that in the Moroccan context, ICT, the use of ICT in teaching does not differ according to gender. So it's not significant. There is any impact of gender in the use of ICT. So these results belie all stereotypes stipulating that female academics or professors use less likely ICT than the counterparts of men. So regarding the determinants of ICT use in teaching, we have noticed that the key factors are age, teaching experience, professor grades, the teaching disciplines, ICT skills, and the characteristics of establishment and the region. And finally, for the professors that are less likely to use ICT in their classroom, are mainly they are young academics or young professors teaching literary disciplines and living in developed regions. who is working in public regulated access establishments and specifically who have just started their professional careers. So as a conclusion, the configuration of this profile is relevant since it can help guide educational policies at increasing ICT in higher education and take advantage of the potential. So the program implemented have focused heavily on the technical aspects of ICT in terms of the quality of platform or the quality of the online workspaces for students or teachers. So this technicist approach has led to neglect much more important factors. So that our results shows clearly that infrastructure alone is not enough, and the ICT is limited by the user's characteristics or by professional characteristics. So to compensate this lack of training for professors at the start of their career, we propose to integrate training on the pedagogical use of ICT in the last year of PhD. Why the last year? Because in Morocco, since 88% of PhD students wish to integrate the higher education sector as a professors. So why not to integrate the technological use or the pedagogical use of ICT in the last year of PhD just before the PhD defense. Also, ongoing training should be offered to update the knowledge and to improve the technological skills of professors. So with that, I will end this brief presentation. So thank you for your attention, and please do review the paper if you have any questions, and post any questions if you may have now. Thank you.
Yeah, thank you, Monir, right?
Yes.
Yeah. Now, the thing is, you were initially talking in your slides about the influence on banking, and then you shifted it to the education part, like the higher education or higher communication model in the research. So ICT is information communication technology, am I right?
Yes, the importance of ICT use or ICT implementation in higher education.
So when you're talking about the ICT for higher communication model, so did you implement this model? When you were showing the results, I
Yes.
didn't see the model or the implementation. So can you please tell me how did you implement it?
Implemented the model. So
Yes,
we took the individual data based on questionnaire, and we analyzed them to see which variable or what are the more important characteristics of individuals who impact their frequency of use of ICT. So after these results, we can, for example, we can use this result to implement some policies, on some strategies based on the main characteristics that act heavily on the use of ICT in teaching, of course.
The question is, how did you implement? I mean, what technology did you use? How did you come to that conclusions that yes, this is the result?
It's based on the ongoing training or vocational training for teachers. That's how we can implement this strategy. Is we took the main characteristics of teachers, for example, the young teachers who are more likely to use less ICT in teaching. So we give them more training to improve their knowledge of ICT use in teaching. So this is how we can implement this the model results for in university or in daily life teaching.
Yeah, may I know which ICT tools have you used?
Sorry?
May I know which ICT tools have you used for vocational training?
the use of interactive platforms with students, the numeric space, the online workspace with students.
All right, thank you.
Thank
Any
you.
questions? Sir?
Okay, so I have no question, but I would like to recommend for the paper. So I think this is only a survey research, but I'm not sure. But I saw only your the result is illustrate only survey, and the sampling is only 223. And your result it should be declare what is the more important things of ICT that would you like to implement for the next contribution. So you have to find out what is the best solutions or the best case or what is the factor that's influencing including ICT, because ICT is wide, so you have to find out for example the statistic. You can use like a factor analysis to analyze what is the mainly important of ICT, is that especially ICT training. So I think you can expand your research for
Do you hear me?
I think so.
Hello?
Probably some internet issue might be.
So as so as you said, the sample is quite low, so we can reanalyze some aggregate data or some data on the national levels to have more reliable results based on this model. And yes, as you said, Professor Kanakarm, the ICT use in ICT is in teaching is quite large term, but there are some ICT tools in universities in Morocco that are important to use. So we have to make more vocational training or this ICT already implemented in universities to increase the chance to use them with students in classroom and in teaching.
Okay, all right. Can we do the next one, Dr. Preeti? All right.
Yes. We
Okay.
can.
Okay, thank you for your presentation. Now I invite Sebastian Bock with his paper on U-shape phenomenon with Gaussian noise and clipped inputs. You may start your presentation now.
Okay. So you can hear me and see my presentation. Okay, so welcome you to the presentation of our paper, the U-shape phenomenon with Gaussian noise and clipped inputs. We start with quite practical motivation in this paper. We start in our project with rotation estimation of images like this. We call it slit disk because it's the disk with a wide slit in it, and we want to estimate the rotation of these components. We specialized us on in industrial settings. Typical work in this area focus on crowded tables and not so clear situations. We are focusing on industrial environments, so we got images that are quite clear. We got less noise, but we need a higher accuracy for probably gripping with a robot or something else. So we want to estimate this rotation of this part in an industrial setting with neural networks. So we do not have to use image process experts. And in this experiment, we got some results. And as you can see in the table, the best for this task are quite small architectures. But that's only I think the motivation for our paper, and that's interesting for industrial partners. And the theory we see in this paper was another. We plotted the error of our neural networks against different noises. So we use to train the neural network. We train the neural network with a fixed noise, a fixed Gaussian noise on the train set. And then we change the noise on the test set. And what we expect at this point was this first expectation. We got a low arrow. So you can see on the left the high of the arrow in the neural network. So we suggest that we get a low arrow with a low noise. So there's no much noise on this image. So probably we think that we also got a low error. The second expectation for us was, okay, we trained with, in this case, sigma equals 0.5. So probably we got there the lowest error of our network. And outside of this noise, we got a higher error. But in fact, if we plot the error in this plot, we see that we got a minimum at around 0.35, and nothing of both expectations become reality. So we look closer to this error of our neural networks, and we simplify the error of our network into this formula 1. This is the important formula for us. And this equals to the error of our neural network. So this is it's a sum over the difference between the label and the estimations of our neural network. We have here the variance regarded to phi and epsilon. Phi is the distribution of our pixels, and epsilon is the noise value of our Gaussian noise, which we put on our data. Then we get f hat. F hat is our estimator. So in this case, it is our neural network, but it also gives us a U-shape if you use supported vector machines or something else. So we call it here only the estimator. Then we get an x tilde. X without tilde is the input data, so the slit disk, the images. And if you put it here with a tilde, we have a noise on it. So we have a Gaussian noise on our image, and we also got a clipped image. Clipped image means we have a gray value image, which means we have pixel values from 0 to 255. But if you probably you have a pixel with a gray value of 0, and you put a Gaussian noise on that pixel, you have the same probability to end up in -5 or 5. But -5 is not a pixel value in the gray value scalar. So you clip all the negative values up to 0, because it doesn't, you can't go be darker than dark. So, and all the negative values goes up to 0. And the same for the white pixels up to 255 all pixel over 255 will be clipped to 255. So our X tilde is noised and clipped. Then we got the bias and a variance. This variance here is constant, so this doesn't affect our U-shape phenomenon. And this term acts like the bias, so we can only focus on the first variance and the bias. And if we plot them, you can see it here. In red, we see again the error of the neural network, and we see again this U-shape phenomenon. And the minimum here is around 0.35 again, and we trained with 0.5. And if we look at the several terms, we see the variance. The variance act like we suggested. If we get a low noise, we get also a low error of our, or we get a low variance at least. And with an increasing noise, our variance increases. So this works as we suggested. The bias acts a little bit different. It has a high error at 0 noise, and the error decreases with an increasing noise. And therefore, if we sum all them together, we get a U shape in our error of our neural network. And the reason why the bias acting like this is the bias variance trade-off. So let me explain this. The bias variance trade-off means you can decrease the error of a neural network by decreasing the variance of the neural network. But if you do this, you increase the bias of the neural network. And the bias means something like it's the ability of a neural network to work with data that not trained in the neural network. So quite new data. And that's the problem we are facing here. We got the bias variance trade-off, so we got a high bias. So we have, there is data outside of the training set. We are performing not so well in our neural networks. The second point is we have much pixels on the edge of our pixel range. So we have much white and much black pixels. You see it in the slit disk image. They are not as much gray value pixels. They are all on the pixel range. And if they are more on the pixel on the edge of the pixel range, the probability increases that we have clipping. And with the clipping, you shift the expectation value of the Gaussian noise. And if you shift that expectation value of your Gaussian noise, the neural network thinks it is a new data and performs badly because of the high bias of the bias variance trade-off. So that's the reason, because we got an U shape in this paper. So thank you for your attention, and now probably there are some questions.
Yeah, Sebastian.
Yeah.
Yep. Like, I have one question. Have you used artificial neural networks?
Yes.
Okay. So in this ANN, the model which you have done is for non-linear data set?
We use several architectures. So we use big architectures, small architectures. We also used support vector machines, and with every kind of architecture or method, we go to the U-shape phenomenon. The only thing which is quite unclear, I think, and it's and further research to do is if we only use one pixel and one neuron in the neural network, so the smallest case, then the U-shape disappear. Then now you're muted, I think.
Sorry. Have you used any data set?
The data set is the slit disk on the beginning of this presentation. The gray slit with the white.
So how did you remove the noise?
We add a matrix on this image, and the matrix is with Gaussian noise.
All right. And a quick one suggestion is like when you're showing the analysis or the graph, in that graph, what represents the x-axis and the y-axis is missing. You can go back to your slide 9 or 8 somewhere.
Wait.
Right. So that x-axis represents what, and the y-axis represents what. So these
the x. Okay, yeah, the x-axis is the noise. So the much of noise we put on our test images in this case, and the y-axis, yeah, it's the error of our neural network in this case, in the red case. In these three cases, yeah, it's the high of this term and this term and this term. So it doesn't have any unit. I think so.
Just a small suggestion. You can just write there that the y-axis represents what and the x represents what. All right.
Yeah.
All the best. That's all from my side.
Thank you.
You have any questions? Anyone has any questions? You can go ahead. Can I go?
I think we're gonna do to the next one.
All right.
Dr. Preeti. Okay.
Okay. So thank you for your presentation. Now moving forward to our last presentation, I invite Ivan Nedyalkov with this paper on using the GNS3 platform for characterizing the traffic in UIP network and study its performance. You may start your presentation now.
Hello, my name is Ivan Nedyakov, and now I'm going to briefly present our work, which is using the GNS3 platform for characterizing the traffic in a VoIP network and study its performance. As you now see and know, the VoIP technology is entering our areas of people life. It's even been using in the 4G and the 5G network in the name of VoLTE. And for an example, it is in 2025 in the UK, the PSTN ISDN network will be discontinued, and all users that are using the ISDN network must change to the VoIP network. Because of this, we need to train specialists who can design, install, maintain, and troubleshooting VoIP networks. How is this achieved? Of course, with training, and the training organization must have the proper network equipment to be able to create experimental networks in which the learners can learn and see what the performance and test the performance of a VoIP network. But the problem here is that not every learning educational can afford to pay the appropriate network equipment. Because of this, we propose to use the platform of modeling of IP networks, the GNS platform, which can be used to train and characterization the VoIP network traffic. The study I am presenting here is divided in two parts. In the first part, we use the GNS3 platform to characterize the traffic in a VoIP network. And in the second part of our study, we are studying the performance of the modeled VoIP network, and the obtained results are presented. The used modeling platform is GNS3. Why we choose GNS3? Because it uses disk images of real operating systems, of real network devices. It has the ability to connect to real IP networks. It has integration with various network monitoring tools, and the last, it's completely free. Of course, it has one, let's say, disadvantage. The working station you need to use to model the network must have high computing capabilities to smoothly run the simulation. The used tools for monitoring and characterizing the traffics are a network packet analyzer, the Wireshark 2, network analyzer, the Capser Enterprise 15. For monitoring and measuring the round trip delay, we're using the Colosoft Ping 2 and the SolarWinds Trace Route NG. And of course, the passive monitoring method. This is the topology of the model network. The study at network has two parts. The one part is this, the model network, which is modeled in the GNS3, and there are a few this modeled network through the here pfSense. We're using it to connect to the real network, and in the real network there is a laptop on which is a soft phone installed. The Asterix IP free PBX is used as IP PBX, and it is again in the modeled network, and there are several users, a virtual machine, which are used for subscribers to the Asterix. During the study, there are calls created between the virtual machines, between the virtual machine and the laptop in the real network, and of course, and VoIP and video calls are created to test the performance of the network. These are some of the results of the characterizing of the traffic in the IP network. This is the generated traffic for the whole period of the study. As you can see, it's let's say huge, because there is a lot of video calls, not only audio calls, but video calls. This is the distribution between broadcast and multicast packets. As can be seen, the multicast packets are much more than the broadcast packets. This result shows the used ports, and it's on the 10 most used ports and the traffic they generate. As can be seen, it's UDP, only UDP ports, because it's multimedia network, multimedia traffic, and it is using the UDP protocol. These are some results for the studying the performance of the study at network. The results are obtained from the Wireshark. Wireshark has an ability for analyzing VoIP calls and video calls. These results are for the, let me see it. Yes, these results are for the video call between the virtual machine 1, which is in the model network, and this is the virtual machine, and this is the laptop in the real network. The most important parameter that are monitored are mean jitter and packet loss. The mean jitter must be below 30 milliseconds, and the lost packets must be below 1%. As can be seen, the mean jitter in the virtual network is 2.58 milliseconds, and in the real network it's below 1 milliseconds, and there is no packet loss. And this is again for only a VoIP call, only audio call between the virtual machine and the laptop in the real network. Again, the values of the mean jitter for both are below the 30 milliseconds, and there is no lost packets. These are the results for the round trip delay between the virtual station, the virtual machine, and the asterisk. The values must be below 150 milliseconds in direction. As can be seen, this graph represents the change of the round trip study for the whole study period. As can be seen, the values is around 17 milliseconds in direction. These peaks are for lags in the computing capabilities of the workstation. This result shows the instantaneous values between, again, the virtual machine 1 and the asterisk, and again the values are below the 150 milliseconds in the direction. In conclusion, a working model of VoIP network has been created in which both voice and video traffic is successfully exchanged. The results of the carry-out study shows that the model VoIP network functions normally. The obtained results are typical for a multimedia type network. The results for the carried out study for the performance of the modeled VoIP network shows that the VoIP network works normally. This is from the obtained values of the average jitter, or mean jitter, packet loss, and the round trip delay. Can be seen that the values are far from the maximum permissible values. From the obtained results, it can be argued that the GNS3 platform can successfully model a VoIP network that behaves almost like a real one, regardless of the fact that it's made of models of network device. The platform GNS3 can be used to train specialists who will be responsible for the design, construction, maintenance, and troubleshootings of VoIP networks. And again, the main requirements for trouble-free use of the GNS3 is that the used workstation must have high computing capabilities. And thanks for your attention.
Thank you, Ivan. Can you hear me?
Yes, yes.
Yeah. So it's a voice over the internet protocol, am I right?
Yes.
Yeah. So you're trying to send the voice and also the videos successfully. You could send that.
Yes. And there is successful exchange between the real network and the model network. And in the model network, there is the IP exchange, PBX.
See, normally what happens is when you send a voice over the internet protocols, you normally face the problems of a delay, or the call gets dropped so easily. Yes. Or there is a audio. I mean, you feel it is connected, but the video is not there. So have you faced any kind of challenges during the work?
The challenges is again in the computing capabilities of the workstation, which is used for the modeling, because it must have high computing capabilities. The workstation that I used before this study, when I'm modeling this kind of networks, there is a lot of lags. It can be easily seen in the results for the round trip delay for the whole period of study. There are a lot of this kind of peaks. But now I changed the workstation with a better one, and now these peaks are very low, only 1 or 2. And this is the main drawback in when using this kind of software for modeling of IP networks. The workstation must have high computing capability, so the simulation can be as smooth as possible, and as I can see it, to be close to real networks. Because if you use a workstation with low computing capabilities, there is a lot of packet loss, the calls drops, or the video is not running smoothly. There is a lot of packets are lost, and it's not very useful to use the working machine with a low computing capability.
All right, Ivan, all the best for the future work.
Well,
Do you have any questions from anyone?
Please, what?
I said good luck for your future work for the year.
Thank you. Thank you.
And if anyone has any questions, they may please proceed with their questions. All
So
right.
could you please, okay, could we please go to the next one? Because the time limit is quite over.
It's done. All the presentation is done. So Saksham, look forward to the closing remarks.
Okay. So I sincerely thank you for our excellent presentation and contribution in this session, and all the participants for being the part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for your support during this 8th version and the previous 7th version of the conference. And we'll be happy to have you in the 9th version of the conference in 2024. All the presenters would be getting their participation certificate within 2 or 3 working days. And further of all the papers are already forwarded to the Springer. So the publications will be live in 6 months. So kindly cooperate with the team. And I also thank our session chair, Dr. Priti Pavekar and Professor Karnakan Panipong for chairing the session. A token of appreciation to the chairs on behalf of Team ICICT and Global Knowledge Research Foundation and partners. Thank you for your excellent presence.
Thank you so much, Aman and Saksham, for giving this opportunity to be an session chair, and nice meeting my co-session chair also. Thank you so much.
Thank you.
Okay. Thank you everybody, and thank you the co-host and Dr. Priti. So I think this good recommend and good question to improve all of the paper, and I was very surprised about her profiles on Scopus is very nice, and so I think her knowledge can contribute to everybody here, and to give a good contribution paper and for next research to all of guys. And thank you for invite me to join the conference. So I think this is a great conference. Okay, I hope
Thank you, Professor.
In next conference.
Yeah, thank you, Professor. I just requesting to all the authors to turn on the camera for the quick snap.
You need to count 1, 2, 3, so we can put a smile on our face.
Yes,
Right.
It's 3, 2, 1.
So we have a virtual camera picture memories. Nice.
Yes, definitely. Thank you, all of you.
Thank you so much. And all the participants, wish you all the best for your research. Bye. Thank you.
Bye. Take care. Thank you.
Bye.